Bam, and there you have it. Now you know how to create a fundamental analysis scanner or a financial ratio scanner. Finance family, it's your other brother Adam Gitbags, and today I'm going to be showing you how to build a fundamental analysis scanner in Python. We're going to be using the Polygon.io API to do that. It's going to be 3 easy steps. We're going to be building our ticker list, we're going to be downloading all the financial statements, and then we're going to create our scanner. So first thing we want to do here, go ahead, Google search Polygon API docs, pull up the API docs here. Here on the right side is our Python client library. You can open that, we're going to need it. If you haven't seen my other Polygon videos, I'll put a link to a playlist here. You can sign in and get your API key. I have an offer for you, it should be 10%. It's going to be in the description as well. So here we are on the scripts, there's 3 of them. First, we're going to go through our ticker list. Now, if you want to get these scripts, they're on my GitHub. I'll put that link in the description too. So very simple. We're just importing a couple modules and then we're importing our API key. Then you can create your client very simply. And then this block is straight from the docs, more or less. So here we're on our Python docs. We're going to go to examples and then we can go to Rust. So then you scroll down here, stocks, tickers.py. They basically give you this snippet here, which you can get the common stock that were actively traded recently, and then it's going to loop through that and then create this list. So I've done a video about getting all the tickers. I'll paste that there. It had a little bit of an error with this active equals true and false, but you can just use this here. That'll get us the list. So let's go ahead and let's just run this all the way through. Now, if you haven't installed the library, you're going to get this error. So let's go ahead and install the library. So if we go to the Python docs, let's go back here to the beginning page. We'll scroll down. Here's our installation instructions. So let's just copy this out. So once you've copied that, then let's open up a terminal. I'm going to go here to my base environment. I know I'm just installing it on my base environment. I really get down like that. So here I'm going to just paste this in the terminal, run it. That looks like it went through. Let's try it again. So common mistake, just make sure you're in the right working directory. You know, I just like let this shit rip. So here we go. All right. So I just had to make sure we were in the correct working directory there. Went ahead, ran that code, and you can see it printed out all of these tickers here. So this can be our ticker list. And then the code right here, all it's doing is sorting these alphabetically. And then this little block right here is saving it to CSV. So we're going to save the symbol column over here to a CSV so that we have a usable CSV that we can use in the other scripts. Okay, so now we've opened this CSV in Excel just to take a quick look, and we can see all of our symbols here. Well, it's only 50 symbols because we're going to try to keep this example concise. Okay, so here we are on our bulk downloader script. This script is going to download all of the financial statements. So here at the top is just everything from our previous script, importing the modules, API key, and then creating the client. Now, we created that symbol list, so we're going to need to use that here, and we're just going to read it in. Now, you don't need to create the symbol list. You can just use a variable, but since these are separate scripts, I've just done it separately. And then next here, we have a download path. So this is going to be the location where we store all of our financial statements. So each ticker is going to have its own Excel file, and each row in the Excel file is going to be a financial statement. So next, I'm going to walk you through the functions and basically how it works. Then we'll take a look at the financial statement object. Okay, so I'm actually going to skip down to the bottom. So we have this bulk download function, which we're going to pass the symbol list, and then we're going to pass the download path. So let's say those 50 tickers, we're going to send them in through here, and then our download path is where the output is going to be. So for each symbol in the symbol list, we're going to go ahead and download the financial statements one symbol at a time. So here we'll go into our financial statement downloads function, which we're going to pass a symbol and then also our download path. So this here is just an empty list. Each item is going to be a financial statement. So here is the basic function that gets the financial statements for one ticker from the Polygon API. So if you haven't seen my Get Fundamentals data from Polygon, I'll put it up here for you to watch. But here's what we're going to use. I'm just going to swap in a ticker right here. So I've just made this quick little code snip so you can take a look. I'm creating this empty list, and then I'm going to save each financial object to our data list here. So we're going to run that through. And then if we want to take a look at the first object in the list, we're going to look at data 0. And then you can see here is a large object, and it also has other nested objects inside of it. So we're gonna need to flatten all of this out, and I'll kind of show you what it looks like. So if you go to the top of the object here, you can see that we have some string values. So CIK, company name, end date, etc. And then we actually have the financials attribute, which has a financials object inside of it. So if we want to take a look at the attributes in the object, whatever, you can use the dir function, and then you can take a look here. These are the attributes that are available. Now, some of them are strings like CIK, company name, but then this financials is a object. So all of the string data, which just doesn't include financials and doesn't include from dict, we're going to save that directly here to a row. So each row is going to be one financial statement. Once we've saved all the string items, then we're going to come here and flatten out the financials object. So here's the financials object that's within the stock financials object. Hope you can follow me. So let's go ahead and take a look at this flattened data function. It's a recursive function, so it just goes through the whole entire financial object and takes everything out. Now here's where it makes sense for me to show you what this Excel file looks like. Great, so here's the Excel file. Each row you can see is a financial statement. So here's the Q2 2024 quarterly financials here for Agilent. Now we can see here's our string data that we've taken out first. Well, it stops here on column J. Then once we get to column K, here is where we start flattening out the nested financials object. So what you see here at the top, we pass it financials data, and then our parent key is financials, and then any additional nesting that's unpacked, we're separating it and then adding the key name, which is separated by an underscore. So here we have financials, and then here's the second key name, balance sheet, and then here's a third key name, which is current assets, and then here's a last key name, which is value. So we're unpacking the object completely, so each value you can see is flattened out. So all these top rows are different keys that are available inside the nested objects. So here, column W, this is our assets, our current assets on the balance sheet. Oh my God. So in my fundamentals video, which I linked here, I show you how to go further and further through these objects to access the different values that are inside the different financial statements. So just so you can really get a picture about how this looks, I'm going to save this financials object to this variable financials data, and then you can look at what this vars function does here. So this creates a dictionary. If there was a dictionary available, we're taking what was previously like a Polygon special object, and now we're converting that to a dictionary. Then we're going through the keys and the values that are available in that dictionary here. We're creating a new key, so we have our parent key, and then the separator, and then the new key. So for example, financials underscore balance sheet, and then we're checking, is this a dictionary? If it is a dictionary, then we're going to go back into the recursive function from the top, and we're going to just go a level deeper, just like in Inception. All right, and the same thing here. If it's an object, if it's not a dictionary object, but it has a dictionary dunder methods, they're called dunder, are they called dunder methods? I don't know what they're called. If it's not, so then if it's not a dictionary, but it has a dictionary method, I think a dunder method, I'm not sure what they're called. I'll just look it up so I don't sound stupid. Dunder methods, I was right. All right. So if it's not a dictionary object, but it has a dunder dictionary method, oh, that's cool, right? Then we're just going to go back into the recursive function. But here we're creating a dictionary from it so that when it shows up, it's a dictionary, and it will make it through like here, right? Once it stops being a dictionary or an object, then we're here, and then we'll add it to our dictionary. And then it recursively does the whole object, flattening it out. So once we've flattened all of the financial statements into this variable, flattened financials, then we're going to add all of those dictionary key value pairs into our row. So now we have all of our string attributes from our first pass. Then we flatten everything out, add it to the row, and then we add this row to our data list. Once our data list is fully built out, Then we're going to create a data frame. If it's not empty, so that means like if there's actually data returned, then we're going to save it as a CSV to our download path as the symbol name. And then if there's no data, we're just going to say that there's no data. So then we just call it right here and we can run it. Okay, so now that I've fixed up the download location, let's run it and let's just see how it works. So as you can see, all of our financial statements begin to populate, and then if there's no data available, you'll see it just says no data available. We can go ahead and open one, check it out, see how it looks. All right, and there you have it. So everything looks good. So now we've downloaded all the financial statements. All right, so that completed, no problem. Next, we can take a look at our scanning tool. So now that we've downloaded all the financial statements, we want to scan through them. So here we have, again, some modules. We have our download path. So next we have the file names. We're just going to go ahead and grab out all of the file names that you can see there. And then we're going to create an empty dictionary for our ratio data. So we're going to be saving financial ratios. We're going to be calculating and saving the financial ratios for each of the spreadsheets. And then we're going to be saving the values so that we can sort by ratio. All right, awesome. So here in this for loop, it's going to go file by file. We're going to go take the first file and we're going to do all of the below and then move on to the second file. And then by the end, we're going to have all the financial ratios for every file. So here we have our first file. Let's just say it's a.csv. We're going to read that file into a CSV, and then we're going to calculate our debt to equity ratio. So keep in mind, these are not individual financial statements. This is a whole sheet of financial statements. So we're calculating the debt to equity ratio for every single financial statement that has data available. So here's the formula. It's pretty easy and you can't mess it up. It's balance sheet liabilities value divided by balance sheet equity value. Now, if you've worked, I'm going to go on a bit of a tangent here, but if you've worked with the SCC API, the video that I made here, you'll notice that the names for the line items on the financial statements are usually different for every company. So some companies might call things different names, and some companies might have different line items completely. So you won't always have a same amount of columns in each of these files, right? And the columns represent line items. And if you took a look at the file for A, you'll notice that sometimes the data is just blank. So like maybe they had a balance sheet account or line item for a certain amount of years, but then they stopped that specific line item. So the data kind of has holes and it's kind of all over the place. So you really do need to go manually if you're going to be doing this type of analysis. This tool is really generalized, right? Like this formula is very simple, and you can almost bet that every financial statement is going to have, every balance sheet is going to have a liabilities and an equity value, right? For total liabilities, total equity. So like that's very easy, right? But if you're doing something more complex, like a working capital cycle, some files are not going to have the data that you're looking for to make those calculations. And then some of the calculations are more nuanced and require a lot of manual hand-holding. So you're not going to be able to do a process like we're doing here for certain financial ratios. So there's other API providers that provide metrics, but then you're going to be relying on them and their methodology for calculating those metrics. And they might not even tell you how they do it. So you won't be able to like verify. So again, here you're trying to blanket a debt to equity ratio across thousands of financial statements and across thousands of companies. You know, how accurate is that really going to be? So that's something you want to think about when you're designing. So we are going to throw caution to the wind and we're going to send these fucking calculations through. So we're going to calculate the debt to equity ratio. Once that's calculated, it's going to be an entire column. So it's for all the rows in that file. Then we're going to locate fiscal period Q3 and fiscal year 2024, and then we're going to get the value from the debt to equity ratio on that specific row. So I'll show you what that looks like. So here we are for A.CSV. We can look at our fiscal period and our fiscal year here at the top. We can see that there is no 2024 Q3 financial statements released yet. So this one is going to be none. This one's not going to show up. If we go to aa.csv, we can see that fiscal period Q3 and fiscal year 2024 is here. So here's Q3 fiscal period, and here's fiscal year 2024. It's right here. So then it's going to grab the new column that we added to the end of this sheet. Well, we didn't add it to the sheet. We just did a calculation where we add to the data frame, and then we're just going to go and select the data point that corresponds to this row right here. So if you want to change out the data point that you grab, you just have to change the fiscal period or the fiscal year or some other combination of columns there. So it's very customizable, right? All right. Then once that comes back to us, it could possibly return multiple rows, right? Depending. So here we're just using where we grab the first data point that's available, the first row of this new data. It's a series, right? So the first item in the series there. And then if not, then it's going to send us none back. Then in our dictionary here, ratio data, we're going to create a value, which is just the name of the ticker. And then we are saving our debt to equity ratio as the value. So by the end of it, then we're going to have this dictionary here. We're going to create a data frame from this dictionary. So we're just creating a list of the items there. And then we're creating a data frame. So this is creating the data frame. And then we have our columns there. We're going to drop any NaN values. And then we're going to sort by debt to equity ratio and just drop the index off. So then we have a nice, neat sorted data frame. So let's go ahead and let's just run this through. So that's going to go for 50 stocks. That goes pretty quick. And then you can see here is our data frame of values sorted by debt to equity ratio, low debt to equity ratio here, negative debt to equity ratio, and then very high debt to equity ratio at the bottom. Bam, and there you have it. Now you know how to create a fundamental analysis scanner or a financial ratio scanner using the Polygon.io API in Python. No sweat. You have my blessing, fam. Watch out for those red candles. Let's go get these bags.